Good afternoon, everyone. Happy Friday. This is Adam Fennick speaking. As you can see, I still am sharing on the screen that we have our schedule. Today we are going to have a talk from Dr. Xander Wang. Dr. Wang is without a doubt an all-star. We are so lucky to have him at the University of Prince Edward Island. He's going to be talking today about mapping the spatial patterns of precipitation in Prince Edward Island. Dr. Wang is the interim associate dean of the School of Climate Change and Adaptation, but he is an all-star because he has a multidisciplinary background in climate science, environmental science, in engineering, geographic information systems and remote sensing, water resources, computer science, statistics, and data science. He's the superhero for what we need for climate change. Having a background in many disciplines so that we can address these issues. So Dr. Wang is going to speak for 20 to 30 minutes. If you have any questions, I'd ask for you to put them in the chat box. And when I return, after we hear from Dr. Wang, I will moderate the questions for the remainder of the time. We will finish, though, at 4 o'clock, and I thank you, 4 o'clock our time here on Prince Edward Island. And I thank you for joining us for this afternoon seminar. So I will stop sharing and turn it over to Dr. Wang.
Okay, thank you very much, Dr. Fennick. Thank you very much for your introduction. And let me just share my screen. Okay, can you see my slide?
Yes, we can.
Okay, great. Yeah, so I will start with give you a brief introduction about my research interests. Then I will come back to talk about today's topic, that is the spatial patterns of precipitation for Prince Edward Island. So here, this is a list of my research interests, including high-resolution regional climate modeling, statistical climate downscaling, hydrological and flood modeling, energy system modeling under climate change, GIS and remote sensing, and also big data analytics and machine learning. And I will give you a quick brief summary about what I have done previously. And one area I have done research that is about high resolution regional climate modeling. And basically we run several regional climate models to generate high resolution climate data for many regions around the world. And these are 3 regional climate models I have run before. And in order to run these regional climate models, we need to use high performance computing clusters, something like this. These are 2 clusters I have maintained before, but now we are using the ACNet high performance computing cluster, which is hosted in the Memorial University for our research. We also do statistical climate downscaling, and this is also to help generate high resolution climate scenarios, but it is based on statistical learning methods. It's basically to build the relationship between large scale climate variables and also local climate variables. It can be from weather stations or gridded reanalysis dataset. And we have developed cluster tree method, which is called a stepwise cluster analysis method, which is similar to machine learning, but we use a cluster tree as a model to represent the relationship between large scale and local scale climate variables. So once we have this cluster tree built, we can start from the root of the cluster tree to do a search to find the leaf cluster. And then we can use the information in this leaf cluster to estimate future climate information. And this method is not only applicable for climate modeling. You can also use that for hydrological modeling and biological classification and many other applications. So that's why we have developed an open source software package, which is called RSCA, and it is available at this address. And we also have a software which can be used to draw the cluster tree generated from this model so that you can visualize the relationship between your input and output variables. And this is the website where you can download this software. And we also developed several climate data portals to share our high resolution climate data. And at this moment, we have the climate change data portal for Canada and China, and also for the province of Ontario and also prairie provinces in Canada. And here I listed the web address of these portals. And we also have some results for Arctic, specifically for Greenland, and also US, Mexico, Caribbean countries, and also some Southeast Asia countries and Australia, New Zealand. And we are working hard to make sure that we can share these, our high resolution climate data for these locations to the public in the near future. But our goal with this new Canadian Center for Climate Change and Adaptation in the St. Peter's Bay in PEI is that to further update and develop high resolution climate data for all nations around the world, so that we can share the data to make sure that people have free and easy access to climate data in order to support climate change impact and adaptation studies. And at this moment, we have received over 800 registered users around the world. And they use our data for different purposes, for agricultural, hydrology, flooding, energy system, or even health assessment. And another area I have done some work that is about urban flood prediction based on hydrological and flood modeling. And this is some here in this slide you are seeing some pictures for the 2016 floods in the Lafayette Parish in Louisiana, United States. And because this city is very flat and there's a river passing through the city, and every time you have heavy rainfall, you will always see the river at certain locations. You will see the reversed flow because the area is so flat. And at this moment, there's no model which is capable of simulating this reverse flow phenomenon, because they basically use the digital elevation model to determine where the water flow at the beginning, and the flow direction will not change during the whole modeling process. So that's a big challenge for all these existing models. So we want to overcome this big challenge, and by developing, so that's why we want to develop a new model which is specifically focused on the scenarios under heavy rainfall, because that's the main reason for urban flooding. And we have developed a new model and to deal with this situation. And we have applied this model to simulate the 2016 floods in Louisiana. And we test out the model. We find that at 50 to 100 meters in terms of the model's resolution, we can reasonably generate, we can reasonably simulate the observed flooding areas at this resolution. And most importantly, our model can simulate the reversed flow, which you can see here, these small arrows, model simulations. And at this point, this is where we observe reverse flow. So you can see the divergence of the flow direction. So that is exactly where we observe the reverse flow. And for energy system modeling, we basically want to focus on climate change aspect. We use input output tables, climate change scenarios, and some optimization models. We combine these together to help us find some effective carbon reduction policies, such as carbon tax or carbon cap trade, or even other options. Okay, now let's come back to today's topic. And for some of you who are not from PEI, I just want to let you know that water is agriculture sector is certainly one of the most important sector for PEI, and water is crucial for our agricultural sector. But due to the current regulations for high capacity irrigation wells, our agriculture activities are actually heavily relying on rainfall. So therefore, understanding the rainfall pattern is really important for local farmers. But recently, our local farmers in PEI have seen, a lot of, increasingly erratic weather patterns across PEI, which brought unprecedented challenges to our crop productions, especially for potato production. And a typical pattern we see is that in the growing season, we have less rainfall. That means it is too dry for the crop. But in the harvest season, we are actually seeing too much rain. So it's probably it's difficult. It's because it's too wet for us to get the crop out of the fields. So that's some patterns we're seeing. So because of we are seeing these kind of patterns, so many farmers have raised some concerns about whether these erratic weather patterns will become a new normal in the future as we adjusting our way to sustain our agriculture businesses. And this is more about seasonal shifts in terms of the precipitation pattern. But there's another question that we need to understand, that is whether there are some consistent spatial patterns in precipitation across PEI. And specifically, we want to know where we have, we typically receive less rainfall or precipitation than other areas. And so we want to identify those dry and wet spots for local farmers so that they can do some planning, maybe in terms of crop selection or even irrigation demands in the future. So in order to answer these questions, we want to first develop high resolution, which is typically 1 kilometer by 1 kilometer climate data for the whole province of PEI. The reason that we want to focus on 1 kilometer is because during our recent observations from weather stations, we see there are significant spatial variations in terms of precipitation. Even for temperature, I will show you the app later on. You can see that the temperature across PEI can also, the difference can also be, sometimes can be 2 degrees Celsius or 3 or even 5 at certain times. So that means it's really important to reflect the spatial patterns when we focus on, individual farmlands or to do some planning for the future. So that's why we need to develop high resolution climate data at 1 kilometer. I believe this is the first time that we want to go down to this resolution. Previously, I have done some work for province of Ontario, but that is for 10 kilometer, which is the highest resolution. But now we want to go down to 1 kilometer. So in terms of the data or the time periods, we want to focus on 3 time periods. One is for historical climate, that is between 1970 to 2000. And this is basically to provide a reference for us to understand the past condition. And then we want to look at the current climate, that is between 2001 and 2020. And this is to help us understand what is the current situation and what's going on with the current pattern. And most importantly, we want to look at the future under different future climate change scenarios. And this can extend from 2021 to 2100. That is the end of this century. And the purpose is to help us understand how climate change will affect local precipitation pattern. And so we probably need to think about how to adjust our agricultural management practices in order to adapt to future climate change. This is just an ongoing research. Today, we'll simply provide some results for the first period, that is for historical climate. And we are working on the current climate and also the future climate. Hopefully, we can provide some results in the near future. So with consideration of these three periods, we're able to answer some key questions. For example, we can answer what is the spatial patterns of precipitation in PEI, and then have this the spatial pattern changed or not over time, and looking in the future, will this spatial pattern continue to change or not under future climate change scenarios? So these are some research questions we want to address. But today we will focus on the first question, that is, what is spatial patterns of precipitation in PEI? So here I'm going to show you some results, and this is a spatial pattern of annual precipitation for PEI, and the data we use is for a historical period that is between 1970 to 2000, and the spatial resolution for this map is 1 kilometer by 1 kilometer. And here we use different color to indicate relatively dry and relatively wet spots. And typically when you see yellow or red, that means this area is relatively dry. And when you see blue or dark green, blue, or dark blue, that means this area is relatively wet. I use the word of relatively because, if you look at the numbers here, they are all over 1,000. If you compare to maybe Saskatchewan, the average is annual total precipitation in Saskatchewan is probably about 500. So apparently, if we compare to other provinces, certainly we are not. There's nowhere which is absolutely dry. So that means here we are just talking about within the context of PEI. And so that's why we want to use the word of relatively dry and relatively wet. And here you can see, based on this map, you can easily see in this area, which is close to here, this is Summerside, and here this is Kensington and Victoria. So you can see in the area between these three cities, and we basically receive relatively less precipitation. And if you look at the east and in Surrey and also Morel River watershed, we have more precipitation compared to other areas. So based on this pattern, we can simply summarize this into east wet. So you can see this is east and it's relatively wet, and west dry. So west is relatively dry pattern. So that is a general pattern we have for the precipitation in PEI. But this is only for annual precipitation. And certainly we also want to look at seasonal precipitation. Here, this map shows you the seasonal patterns from here. This is the winter, spring, summer, and fall. Again, we use the same color code to indicate the relatively dry and relatively wet spots. And you can see, if you look at the seasonal pattern, and apparently spring and summer will receive relatively less precipitation compared to fall and winter. And furthermore, we can even aggregate the seasonal pattern into monthly. And here we have 12 months from January to December. And again, we use the same color code for to indicate the relatively dry and relatively wet spots. And you can see, especially in summer and in the spring, we have relatively less precipitation. But starting from September, we start to receive more precipitation, and then into October, November, December, and then January. So these are the months that we receive more precipitation. So because these are November, December, they are mainly in winter, so that's certainly snow. We doesn't have snow doesn't help with our agriculture, but certainly will help with our groundwater recharge. But local farmers probably will, will be concerned about the available rainfall in the growing season. So that's why we also sum the precipitation from June to September together to indicate the total precipitation to be received during the growing season, so that you can get a sense about the spatial pattern for growing season. And here, this is the map for growing season precipitation. And generally speaking, the pattern is similar to the annual precipitation pattern. But if you look at the, the relatively dry and also the wet spots, you can see there are some slight spatial shift. And here you can see the dry area mainly, centering the town of Victoria. And then for the wet area, it's more about more between Surrey, North Lake, South Lake. But previously, if you look at the annual pattern, you will see here in Moreau River, there's another wet spot. But here you can see compared to Surrey, they still receive relatively less precipitation. So this is about the seasonal pattern. And here, this is just about the spatial pattern. And some people actually are more concerned about the quantity about rainfall. So here I have a table listing, the total rainfall for 4 seasons, annual and also growing season. And if you look at the annual values, and here we have the minimum value, which is it's just about 1 sovereign, but the maximum can be 1250. So that means the difference, even though PI is very small, then the difference in annual total precipitation can be about 250 millimeters if you look at the whole year. And if you look at the growing season, and the difference can be about 80 or 90 millimeters from the wet spots to the dry spots. So again, that's a lot for potatoes. So this is about the numbers. We also have the statistics for monthly precipitation, and here you're looking at the 12 months statistics from January to December. And I will not read these numbers, but instead I'm going to show you this Zeta plot to give you a sense about the monthly distribution. And here you can see we use this plot to show the pattern from January to December. And basically in the spring and summer months, we receive less precipitation compared to fall and winter. And if you look at the standard deviation, which describes the spatial difference or the spatial variations in terms of precipitation across PEI. And again, you can see in spring and summer months, the standard deviation is relatively small, but in the fall and winter, the spatial variation is pretty large. And this is from the climate perspective or meteorological perspective. The largest standard deviation is probably caused by the ocean effects or the sea ice effects in the winter about the snow distribution. So certainly there are many discussions on this aspect. Okay, so I have prepared a detailed report for this small project. And if you are interested, you can go to this website. This is my personal website at UPI to download this report. And we also have a number of other climate change report series. And so you can also refer to other reports to learn more details about some of our other projects we have done. And So next, I'm going to give you a brief intro about the weather and climate app, and also other two apps we have developed recently. And because this is more about, this topic is more about weather or climate, so I want to share this weather and climate app. And this is a web-based climate app, web-based app, which you can simply access it with your smartphone, tablets, or desktop or laptop, and you can simply type this address in the browser. Then the app will automatically adjust its user interface into your device. And this is just a screenshot about the app, the homepage of the app, and this is a screenshot I have made maybe a few weeks ago. But if you look at the current map, the outside temperature is probably -7 or -6. And but I just want to show you from this screenshot, if you look at the values, and here at the east or south, you can see the temperature is about 1 or 0 or -1. But if you look at the north and west, you can see it can be -7 or -5. So that means even though we are a small island, our temperature can vary significantly. And not to mention about precipitation or rainfall. And because it's very common to see, especially in summer, this area is raining, but another area is just sunny. So that means it's really important to use high resolution climate data to reflect these kind of spatial variations in local climate information, so that we can make some decisions, climate smart decisions. Okay, so these are some of the stations we have. You can click on each station to look at the details. And again, this is just an example about one station. So when you click on this station, you can enter its individual web page, and you can check the time series data for the past day, past week, and past 30 days. And you can also download the data from the web page. But if you want to download data, you need to register an account. It's a very, very simple process. We just want to use this registration process to help us understand what kind of purposes these data are used for. So here you can see this is the past week's trends for this station. And we have temperature, precipitation, wind speed, humidity, dew point, and also solar radiation. And we also integrate let me go back to here. If you look at the screenshot here, at the right bottom, you will see a camera icon. You can click on this camera icon. You will see the road camera. And here we basically integrate the road cameras from the Department of Transportation, and also some real-time camera for the city of Charlottetown downtown area, and another camera I think is probably for the ski park in PEI. So it's basically gives you a sense about what the outside looks like. And if you want to check maybe the road condition or some other conditions. And you can also switch to climate if you want to look at long-term trends. And here I just want to mention that at this moment we only include 3 Environment Canada stations, because when we talk about climate, we need to at least have 30 years of data to talk about climate. And for all these stations in our weather app, most of the stations, they are pretty new. We probably only have 5 or maybe even 5 or 8 or 10 years of data. That means the record is still not long enough for us to some calculations or statistics about climate change. So that's why at this moment we only have 3 stations from Environment Canada. And again, you can click on these stations to learn more details about each station. You can look at annual values, annual statistics, monthly, and also seasonal statistics. And you can also change the start and end year to generate different plots to give you a sense about what the historical climate looks like at this station. Again, you can also download data if you want. So at this moment, we have received 220 registered users. As I mentioned, we only ask user to register an account when they want to download data. If they don't want to download data, they have no need to register. So I believe we have more users if we simply look at more users who are just exploring the map and maybe just using the real-time weather information for some planning purposes. And we also have two other apps, which I think some of you might be interested. One is the PEI Storm Surge Early Warning System. And this is its official website. And currently we have 7 real-time water level stations and to monitor the water level. And we also compare the water level to the top of the wharf. If the water level is too close to the top of the wharf, then we will send out a warning email to the registered users so that you can at least make some decisions, maybe just avoid going to these areas because it's likely to be flooded during the storm surge. And we also have another app that is a PI Climate Diary app. That is based on Dr. Adam Phoenix's previous, the work for the printed version of Climate Diary. And here we just want to digitize this Climate Diary so that people can simply use this as an app in their smartphone or tablets or even computer to do some, to help record some information, which is more about field knowledge. And so that we can use this kind of information to help us understand how the climate change is changing. And here you can see many icons. You basically can report what you see for the first time, like for a bird or animal, or even some new plants. This will provide some information which will link to climate change, so that we can use this kind of information to study climate change also. Okay, so here just a list of ongoing research of my group, and we are currently working on a 1 kilometer by 1 kilometer high resolution climate projections for PEI, and also we also want to do seasonal climate predictions for PEI and flood risk mapping for PEI, and we also have some small projects on climate change impacts on agriculture, maybe crop yields and species at risk, and also climate change impacts on forests in PEI. And these are some funding agencies. They provide funding for my research, including UNSEC, National Research Council, ACOA, the provincial government, and also Climate Science Program. And I just want to thank them for providing the research support. And that's all for my presentation. And here, this is my email. If you want to require any further information about today's topic or maybe the slides, you can simply email me. So I'm going to stop here. I'd like to take any questions you have.
Thank you very much, Dr. Wong. This is Adam Fennick back speaking. You can see why I call him one of our superstars, our superheroes, from talking about looking at historical data, current data, future data, climate modeling resolution, looking at web tools, web applications. I think we're going to have to start calling you Captain Climate. So if people have a question that they'd like Dr. Wong to answer, please put it in the chat box. So I'll give you a couple of minutes to do that because I have my own questions for you, Xander, if that's okay.
Yes, yeah.
So when you were talking about doing the historical 1 kilometer by 1 kilometer, how many stations did you utilize to create that that spatial pattern map?
Yeah, that's a good question, Adam. And at this moment, we only use the interpolated greedy data sets from worldclimate.org that they basically use the public available weather station. I believe should be those stations from Environment Canada. And also the good thing is that they incorporate the satellite data and also the topography, because the top of mountain and the bottom of the mountain can be different in terms of temperature. So yeah, they incorporate this kind of information to generate these interpolated results. But I guess they certainly don't have enough stations, just like what we have at UPI. But I think because we don't have enough records, so and also it's this data set is only for 1970 to 2000, so it's not for the current period. So that's why, in order to overcome these shortcomings with this data set, we are currently collecting all the data from various sources, from the Environment Canada, from the weather on ground, and also other personal stations. As long as it is open to the public, we want to collect the data for precipitation so that we can generate more accurate patterns for PEI, especially for the recent 20 years. So that's something we are working on. But I just want to acknowledge for this data set, I do believe there should be some issues in terms of the number of stations considered in the data set.
Okay, so it's an interpolated data set, which means that it takes what existing data is available and then uses statistics as well as other data, such as you mentioned, like satellite data does collect at different resolutions, does collect temperature through the atmosphere. You also said topography. So the data set itself, though, at what resolution was it provided to you for you to make those maps? Was it at 1 kilometer by 1 kilometer?
Yeah, it is at 1 kilometer by 1 kilometer.
Okay, so
Yeah.
and they determine that spatial pattern historically by utilizing they say public data sets and the topography. Now, is that how you plan to replicate? Like, are you going to replicate their methodological approach to determine the current climate and the future climate?
No, that's not the purpose we want to. We basically want to use their data as a reference for comparison. And we are in the process of generating our own data sets based on all the available weather station data. So this is once we have this have the data from all stations, we want to test on different spatial interpolation methods, and also to maybe pick up top 2 or top 3 methods to generate some maps for PEI. But this is only for the current period. Moving into the future periods, we don't have weather observation data, so we certainly need to run a regional climate model first to generate maybe 25 or 10 kilometer resolution data sets, and then we are going to perform statistical downscaling to downscale this data into 1 kilometer. So that's something that we are going to do for future climate. But this data set will be used as used for test the performance of statistical downscaling methods, so that we can select a reliable method for future projection.
Okay, yeah, so that's that's a lot of work ahead of you. I know the evaluation of the finest resolution of a climate model that I've seen for Prince Edward Island would have been 10-kilometer, which was provided, it was developed for the Department of Agriculture, the Federal Department of Agriculture, using an annuspline methodology, which does take into account the elevation or the topography, as well as something else that slips my mind. That annuspline, or that type as well, does provide, shows that there is this variation across the island, even though the elevation changes are not very high. I mean, you talked about mountaintops, but our elevation, I think, don't quote me, but I think it's from the highest to the lowest point on the island is about 160 meters, so it's not exactly huge. It is a fairly flat island where we are. The other question I had to do with the time step for this 1 kilometer by 1 kilometer model, but the one that you showed, I'm assuming then it's just for that entire period from 1970 to 2000. So it's actually a 31-year time step. Is that correct?
Yes, you're right, Adam. So at this moment, just presenting the average for the whole period. Yeah. But what we are working now is to collect individual years so that we can also provide a time series for the pattern. Each year, you basically will have monthly, seasonal, and annual maps showing you the pattern, and we can compare or maybe simply generate animation from the starting year to the end year so that you can see how the pattern is changing over time. So that's something we are working on.
Okay, we have 9 questions, so I better, okay, let's see what we have here. A lot of thank yous. The same question came from Don Jardine about which stations were used to calculate the historical maps from 1970 to 2000, but we answered that one. I have one here from Dr. Irene Novacek. How do you think trends in precipitation will affect soil erosion into rivers and estuaries?
Well, I think someday this is more about the hydrology side, and certainly the trend or the incoming water from the atmosphere will certainly affect the erosion, soil erosion in PEI. And it also, when we do hydrologic modeling, precipitation is the input. So that means it's critically important. But another factor is about the topography and also the land cover or land use. So if this area is very flat and it is covered by some maybe forests, and then the surface runoff is actually not that obvious. So I guess in order to model this, we really need to consider all these factors together to do a systematic model simulation. But I would say precipitation is certainly the major factor for soil erosion, and certainly because it's just the input of surface hydrology. So if there's no precipitation, there's no runoff. So that's something I think it's important.
Thank you. The next question comes from Louis Doiron. And I think it goes back to your statistical downscaling slide, because he's asking, are you applying probabilities to each branch of the cluster trees stochastically?
That's a really a good question, Louis. And we at this moment, we don't apply probabilities. We basically use the multiple ANOVA analysis, and we use a statistical hypothesis test, and which is based on the p-value of the and to determine. I should say again, p-value is a probability, but it's not like you quantify the uncertainty. It's more about use a statistical test to determine the statistical significance in terms of the difference between these two clusters. So we use a ANOVA analysis to determine that factor, and we choose different significant levels from 0.05 to 0.01, so that we can test on the sensitivity of different cluster trees towards these related to different significance levels. And then we also use our separate validation data set to test which one is the best. But I guess we do consider probability, but it's more about the hypothesis test side.
Thank you for that. Can you hear me? Yeah.
Yes, I can.
Okay, just to add to that, if you did, I guess you could be doing some stress testing and scenario testing, which you likely are not doing right now, I suppose.
Yeah, at this moment we don't do that, but certainly it's a good suggestion. Yeah, that's great.
Maybe we could work together on that.
Certainly, yeah, I would be happy to discuss with you further about this collaboration. Great, thank you very much, Louis.
Yeah, and I would just add, when I was looking at your maps, in terms of amounts of precipitation and temperature, in a way, PEI Island is situated almost right on the jet stream. So in a way, I was not too surprised of your findings, because the east side of the island is along kind of the bottom of the jet stream, while the west side is above. So the weather comes from the north, and it's colder on the west side, and it's kind of warmer on the east side, and also it gets all the wetness from the ocean from the US East Coast, so it gets more wet, right? So in a way, it's, yes, we are on the sea, but we are also affected by the position of the jet stream.
Yeah, you're right, Louis. You are an expert, actually. Yeah.
So
that's a major factor. Yeah.
the next question comes from another of your colleagues, Josh McFadgen, who has a question about your app, web app development, and I assume he's talking about the Climate Station one and the Climate Diary one, as well as the early warning system of storm surges. So he asked the question, can you talk about how scalable these kind of app development is? How difficult would it be for other maritime communities or even the whole province to build their own?
Well, I think for these apps, if you want to apply to other provinces, it's quite easy because the framework is there. But we currently basically limit our spatial extent to PEI, and but from the technology side, there's no barriers for us to expand that to cover the other maritime communities. So I think it's totally scalable, and we can even scale this to the whole country if needed. And I believe the framework of the app is already there. So it's more about from the data side, especially for the weather and climate data, the climate app. It's more about the infrastructure side. Do we have enough stations to cover the whole pattern or not? As long as we have these stations, we can easily plug them into this app. So I think it's quite easy for us to extend to other provinces.
Yes, and I mean that's the beauty of researching on Prince Edward Island, is that you can develop things here that it's large enough to make a difference, but small enough that you can sort of be completist about things. But Josh, just for your own information, the new climate school and the climate center and the climate lab, we've applied to Environment Canada a recent request for proposals for running all of the Atlantic climate services over the next few years. There were 3 responses to the RFP, but we have yet to hear back. They did promise that they'd make a decision before the end of March, so I'm surprised we haven't heard anything yet. But certainly, if we're able to get the resources that come with that designation as well, it will allow us to take a lot of these tools that we've developed and expand them not only across the whole Atlantic community, but also, like Xander says, perhaps get them adopted across the country. All right. Don Jardine has another question that asks, do you plan to incorporate data from the CocoRAS stations into your network? So I think either you can explain CocoRAS or I can. Would you like me to explain?
Yeah, please go ahead.
Okay, the CocoRAS, it is this this kind of crazy acronym that they put together. It was developed in the United States, the American Meteorological Society, because what was being seen is that the climate stations weren't able to capture the extreme intense climate events because they were so small on a spatial level that they would be happening often between the climate stations, but even the climate stations themselves, without some very expensive additions, could not measure certain things. So the CocoRAS network, it relies on volunteers. Now they're trained volunteers that use a standardized set of equipment to measure such things as snow depth, to report on hail, and other things that you just normally don't see when you're looking at the climate record. But if I guess that's the question: is will we be able to implement the CocoRAS stations into? I assume that means the web app.
Yeah, I think yeah, one challenge for us is that because for this app we want to provide real-time information, but for those CocoRAS stations, it's basically need to manually measure the rainfall or snow for after a certain time. So so that means there's a timing issue with that. But the accuracy, I just want to acknowledge the accuracy of these stations, because manual measurement is actually, sometimes it's pretty accurate than automatic weather stations. And I think that's something that we just want to discuss or maybe consider in the near future, because there's another problem with this app is we are just showing the precipitation rate. That is simply about the a very just a rate. It's not about the past day total precipitation or rainfall, but that's many farmers, they actually want to get this kind of information for maybe the past day or past 2 days, and similar to the CocoRAS. So I guess we probably need to consider a way to incorporate the CocoRAS information stations into this network. From a technical perspective, I don't see any issues. So that's only the only concern I have. This is about the if we are providing real-time or not real-time information. But I guess moving forward, is certainly I have heard a lot of comments about this. Certainly, I guess we probably can add past day total rainfall into the app based on CocoRAS and also our existing weather stations. And it will provide more useful information for local farmers, I think. Yeah, but this is certainly in progress. But yeah, I think it's doable. Yeah.
Thank you, Xander. We have another question. This comes from Toyin Adakambi, and she asks, "What factors does one need to consider before mapping spatial distribution?"
Well, I think in terms of factors, certainly you want to make sure that when we talk about the weather, you need to make sure you have good coverage in terms of the spatial geographic locations of weather stations. It's not only about the total number of stations. It's also about their spatial distributions, because we know that it's for precipitation. It's very obvious for us. There's some spatial variation, so it's important to make sure that these stations are well distributed for your study area, and then you can easily capture the pattern. Otherwise, it's very likely to miss some spots that you don't, because you don't have any observations. So I guess that's the major factors for before you consider this to generate some spatial patterns.
Thank you. Dr. Irene Novacek has another question, and it refers to the intensity of precipitation. You know, your maps were showing general patterns, but we didn't talk much at all about the extremes. So her comment first is that you know, we hear the precipitation is definitely going to be less in the summer, but more intense in other seasons. If this is in the spring and the fall when the soil's bare and more erodible, then erosion may increase. So her question is, do you see an intensification of precipitation in the future, in the spring or fall seasons? Is that something that you have evidence of, or just from your own general knowledge would anticipate?
Well, thank you very much, Adam, for reading this question, and thank you, Irene. Yeah, it's a great question. For this ongoing study, we haven't yet collected the information which can help us to understand the extremes. But as from my general understanding, certainly the intensification of precipitation will become a very important issue. But I'm not sure about the seasonal patterns. Like will this the intensification will mainly in spring or fall? I'm not sure at this moment, because we don't have enough data at this moment to look at this. But based on my previous research with Ontario, I think the main it's more like in two seasons, in the summer and also in the winter, because of the Great Lake effects, and it can regulate the local precipitation, snowfall, and rainfall a lot. So certainly this kind of intensification is more likely to see in winter and also in summer. But I'm not sure. I'm because we don't have any results yet for PEI, so I cannot specifically say anything about this. But we will see after we get some results. I think it's certainly a great question to look at once we have enough data for that. Thank you.
I think this is going to have to be our final question, which comes from Emily Murphy, who is doing a wonderful thing. She's integrating my seminar from last week to yours. So she said, Dr. Fennick showed drone data of field moisture levels following irrigation. Is it possible to use a similar approach or collaboration to validate in real time the spatial patterns of seasonal precipitation here on Prince Edward Island?
Well, that's really a great point. I think, yeah, I haven't thought about this, but certainly there's some potential to use that, and especially when we focus on validating the spatial patterns using these drone images, because it can cover a relatively large area. Because if we only use weather observations, it's just about a point. But if we use the images from drone, and it covers a bigger area, and certainly it will help us to understand the spatial pattern. But one issue I think is because even though you cover a home farm field, but it's still relatively small. And if you look at the precipitation, I don't see any significant variation in terms of each farmland. But if you look at a bigger region, certainly there will be some differences. But at this scale, the difference might be not that significant. But again, from the data perspective, it certainly will provide more data for us to validate the model.
Well, thank you so much, Dr. Wong. We've really enjoyed your presentation today and your fielding of questions. I'd ask you, Xander, to stay on this seminar as we have a brief meeting following. To everyone else, thanks for coming. I just wanted to remind you that next week we're going to have Charlie Sark from the School of Climate Change and Adaptation talking about climate colonialism, how decolonizing our food systems can decarbonize our consumption. So thanks again, and I hope to see many of you next week.
Thank you all.
There we are. We're down to the three of us. Welcome, Louis. You've met Xander. Have you met Louis before?
Yeah, you know what? We are neighbors.
Yeah, we are immediate neighbors, actually.
Oh, wonderful, wonderful. I told Louis that I only have about 10 minutes, but that if we wanted to meet following, we can certainly get together afterwards. So why don't I pass it over to you, Louis?
Very good. Just to let you know, Adam, Xander and I had a great meeting already a few weeks ago about the idea of working together between the actual science department and the climate change, you guys' climate change area. And that was an idea of mine because I recently joined the climate change committee of the Canadian Institute of Actuaries, and I just wanted to get some ideas from Xander of the feasibility of my idea of possibly working together. And then after our meeting, we realized that maybe it would be possible to have some kind of what seemed possible between Xander and I because of your new building in St. Peter's being constructed, right? And the structure of the program being in groups in kind of 6 hours sessions as opposed to the regular 1 hour and 15 minutes, right? So what could work is like a 1 year certificate, at least that's the idea at this point, to be added to the so kind of an actual climate change certificate, which would comprise of several courses that would be taken with your faculty over the last year, let's say a fifth year of the already 4-year actual program in St. Peter's, and as well as a couple actual courses that would wrap it around that, and that would create, let's say, a 10, 11 courses of a certificate altogether. Let's say eight courses from climate change, 2 courses from actuarial. And the 2 courses from actuarial would be really the fact that the insurance industry and the banking industry and the investment industry, including pension funds, is developing very rapidly serious concerns about climate change and the impact of course, of climate change. As we talked today, right? The impact on agriculture, but of course, insurance ensure crop insurance and things like that, so they be directly affected. The damages to buildings. Already, my insurance is renewing on my house in May, and they retrieve for the first time tsunami, séché, and tidal waves from my insurance. So because I have a separate coverage for earthquake and flooding, and from the flooding rider, they excluded tsunami, séché, and tidal wave, which would be the only possibility. Xander knows where I live, so the possibility that
For
we would get
flooding. Yeah.
flooding, right?
It's true. It's
And
very
both
true.
sides, Xander and I live more above than below, so we cannot really get sewers backup or anything like that. So already, I think, insurance coverage will become more and more expensive, more and more unavailable. For example, in Australia, if you live close to a fire area, a forest fire area, you cannot be insured anymore. So, and pension funds, the investment, the green investment, it will affect also all the corporations, right? Because of losses of all kinds. So the interest there is definitely there. So that would be kind of the 2, 3 actual courses on climate change that would talk about those things, but also like, let's say, 7 to 9 courses on pure climate change. And the demand, of course, growing demand from the banking, the pension fund, and the insurance industry from the financial side. Just to let you know, right? For example, the Bank of Canada now has a climate change area. The OSFI, the Office of the Superintendent of Financial Institution, which monitor the insurance fundings and the bank fundings, also now has a climate change rulings. And I could send you copies of those things. It's very, very exhaustive that the committee that I'm working on the CIA is doing. And as you and I talked about before, right, about for the last 3, 4 years, the actuaries have done a climate index, but now it's moving like high speed. So I think there is a possibility here, and looking at Googling that, we would be the only university so far that would have an actual program. And I'm sitting on committees of the International Actuarial Association, the Society of Actuaries, the Casualty Actuarial Society in the US, the Canadian Institute of Actuaries. So we could attract students from worldwide, right, with something like that. The only university that I'm aware that has a climate change program is Waterloo, but they don't have a link yet with the actual program, and they are not, as you pointed out in the presentation today, Adam, they are not situated on an island, so we are much, right, we are at an advantage here in terms of monitoring and so on. So I think we will not remain the only university having an actual program, I'm sure, let's say 5 years from now, but we would be probably the first and one of the top ones, with because first of all, to have that, you have to have a climate change area in your university, right? Which only a few universities. Let's say if Dal wanted to do that with their actual program, which is not as good as ours, or let's say Laval University, they don't have a climate change program, right? So it has to work together. So that's
Well,
the idea.
that's a good idea.
And
Yeah.
after my meeting with Xander, I brushed the idea with Allah by email, just saying, we had a great meeting, Xander and I, because Allah had sent, because at the Senate, when Xander was invited, I had mentioned the possibility, and Allah had replied that he was very excited about Xander and I working together. And then after our meeting with Xander, I sent an email to thank Allah for his email and saying, here's what we discussed. And he called me. He said, I want to talk to you as opposed to just reply by email. And I would like you to talk to Adam and Xander again. And because he was very excited by that. So
Yeah, I think well, I think we'd be honored. I see the benefits much the same as you do in terms of it being sort of a leading edge. Insurance, we're the ones pushing over the last 15, 20 years to keep climate change up onto the agenda. And it's reflected in our, when I, 30 years ago, my automobile insurance was 3 times the price of my house insurance, and it's now the same or even more my house insurance. So it's just that reflection. There's a lot of discussion we've been pulled into just because of our Clive tool to assist in because there's been a push from the Insurance Bureau of Canada to develop flooding insurance for Canada, similar to the agriculture insurance, where the premiums are paid a third by the feds, a third by the province, and a third by the farmer. So so I think it'd be ideal. I think we'd welcome very much. The issue would be, which I'm going to leave to Xander to figure out, okay, how do we do this? And I think the
Right.
three of us should talk next week to talk about it as more of a non-regularized certificate program. In other words, we should try and do it, try to use a model, I think, I'd like to discuss with you. I want you to think about it. The model that they have in education, where there's 3 weeks of intensive study, meaning 9 to 5, 5 days a week during the summer, early summer. And then there's 2 courses online, maybe more, I don't remember, and then 3 courses at the end. And that's how we had patterned a master's program to exist. So we'd have the space at the new building because our current program doesn't go beyond April. So we'd have the space if we wanted to do it, let's say in May or June. And we could even think about, maybe we even compress it more and just say, oh, come for 6 weeks and we're going to do it day and night to get to. I think there probably should be more of an actuarial emphasis, or it should be, we should create the flexibility for those coming out of a climate program would have to take more actuarial courses, and those coming out of an actuary program would have to take more climate. So that there might be, maybe 8 courses on either side, but it depends on which stream you're coming in and what your background is. But anyway, it's a great idea. Let's do it. Let's set up a time next week. And Xander, if you could give some thought as to how do we develop certificate programs? Maybe it's a master's program. Maybe it's something really crazy like that.
Yeah, I want to avoid going to MPHEC at this point if it was right. So that's why I was thinking certificate initially, because a master
Sure.
would require that, right? So, but I agree. I mean, once we start a base, we could go anywhere. Already Xander and I in our early talk had identified some year 3 and 4 courses. Because remember, these people, at least from the actual side, and in a way, the same. It could be the same from from the climate change side. Would be people from already having completed their 4th year, right? So already like mature students. So mature actual students are definitely higher IQ. The ones that reach the 4th year. So I've done that already with economics to waive some prerequisites, so they take the more advanced economic courses without taking the early courses. And Xander and I had identified about 8 courses of year 3 and 4 that could be taken, and then I could create, let's say, another 4 courses in actuarial, and I mean growing that, of course, right, with the demand, and both sides could take the actual courses, and my student could take, let 6 to 8 climate change, and that would make the certificate. That's what we were
Let's
thinking.
let's set up a time next week.
Okay.
Because I want to respond to that, but I don't have time. So
And I'm
sounds
with
great. I'm on. And Ala mentioned something. All he said was talk to Louis, and I said, well, I owe Louis a call anyway, because you would mention at one time saying, how do we start collaborating some more. So okay, thanks so much. We'll
Sounds
talk.
good. So what I will do, I will just fire an email right now to both of you to get some time. We are just 3 of us. I won't do a doodle,
Sure.
but you guys. I mean, yeah, sounds
Sounds good.
great.
Bye-bye.
Thank you so much. Bye bye now.
Bye bye.